Now we will see the ionization of polar covalent compound. We have already discussed with you the what you can say the decomposition of there is sodium chloride. If you take the molten sodium chloride, what is going to happen? If you take solid sodium chloride, what is going to happen? So I have told you already that solid sodium chloride, in the absence of ions, it does not conduct electricity, but in the molten state or the fused state, these ions are set free, and hence due to the availability of free ions, it helps in the conduction of electricity. Already I have talked with you all these things. Now today, as I said you, we are going to study about the polar covalent compound. Now polar covalent compound like HCl, ammonia, you see these compounds, they are soluble in water. Even last class also I told you about it. Alright, so polar covalent compound like HCl, ammonia, they are soluble in water. So in the gaseous state, these are poor conductor of electricity. Because you know that electrolyte, I have already said you many times, electrolytes are never gaseous. They are either in the molten state or in the aqueous solution state. So gaseous ammonia, gaseous HCl does not conduct electricity. Same thing due to the absence of free ions. Due to the absence of ions. Free means they don't have ions at all. So what you do is that you dissolve HCl in water, you dissolve ammonia in water. So when you dissolve HCl ammonia in water, ammonia and HCl is highly soluble in water. We have studied already. Due to the high solubility, what happens is that water, as it is having high dielectric constant, I told you the last class, it helps to ionize, not dissociate. Don't use the word dissociate here. It helps to ionize HCl into H plus and Cl minus ions. And it helps to ionize ammonia into NH4 plus and NOH minus ions. Now due to ionization, listen carefully, due to ionization, the ions which are produced on dissolving this polar covalent compound in water, got it? The water is what? Water is a polar solvent. HCl ammonia is what? Polar covalent compound. So any polar covalent compound which is soluble in water, which is soluble in polar solvent, conducts electricity. Got it now? What I said? That is HCl and ammonia, when you dissolve in water, it ionizes. It ionizes in this way. HCl dissociates to give you H plus plus Cl minus. It ionizes in water, in aqueous solution. You can also write, that is nothing but water, you can write it, which gives you H plus plus OH minus. Alright, clear? And hence it conducts electricity. Same thing with ammonia also. Ammonia, when it is dissolved in water, I can write it in one step also. You can write it in one step also. If you want, you can write it in one step. It dissociates to give you, what is that? It gives you, that is nothing but NH4 plus plus OH minus. Or you can write in two step also, you can write it down. Clear? So in this way, that is, you can see it produces the ions, and these ions helps in the conduction of electricity. In one step, what you write it down, this one, HCl plus water is nothing but H3O plus plus Cl minus. That is, hydronium ions is produced and Cl minus ions is produced. Means ultimately ionization takes place, and due to the presence of this ions only, it helps in the conduction of electricity. We can say that. Alright, and one more thing I told you also the last class, the previous class, that pure water is a non-conductor of electricity. Pure water does not conduct electricity at all. Pure water never conducts electricity. Why? Because pure water is a non-electrolyte. Pure water is what? Again, just like HCl and ammonia. HCl and ammonia, they are gaseous. They are covalent compound. Pure water is a liquid. It's a covalent compound. You know that. Pure water means distilled water, mean to say. Alright, it does not conduct electricity due to the absence of free ions. Because there, the what you can say H, that is hydrogen and OH, they are held together by strong covalent bond. Alright, that is hydrogen and oxygen, rather I should say, they are held together by strong covalent bond. When you add some acid to it, but remember, acid means it's not that any acid you'll be adding to it. You can't add HCl or nitric acid to it. You have to add sulfuric acid. Why? Because HCl and nitric acid, they are volatile acid. Moreover, nitric acid is an oxidizing agent. It will oxidize readily. So it will interfere with the reaction. It is going to interfere with the reaction. Remember it. So for acidification, always we add sulfuric acid. In your house, the inverter which you are using, the battery which you are using, are you adding HCl or are you adding nitric acid to it? No, sulfuric acid. You are adding sulfuric acid because sulfuric acid is a non-volatile acid. It's a non-volatile sulfuric acid. And these two are the volatile acids. So it may volatilize out. It may interfere with the reaction. Moreover, nitric acid, you know, is a strong oxidizing agent. Got it? And it may oxidize due to this particular, what you can say, due to oxidation, it may interfere with the reaction. Alright, you may not get the desired product, what you want. Alright, the desired product which you want, that you will not get it. What is the desired product you want? You want that water is non-conductor. By adding acid to it, it becomes conductive. You does not want that this product should be formed or that product should be formed, or it will oxidize to give you this reaction or that reaction. No, not at all. I want simply the role of an acid here, simply to make the water conductive, simply to make the water to dissociate into, to make the water ionize into its ions. That's it. That is my role. We need to understand that why I am adding this particular one. It's not that no HCl will do, nitric acid will do, never it will do. Because that is not the role of HCl and nitric acid when you add it to the water. Because HCl and nitric acid, again I repeat, it's a volatile acid, whereas sulfuric acid is a non-volatile acid. Nitric acid may interfere with the reaction, alright, due to its oxidizing nature. It's a strong oxidizing agent, but sulfuric acid will not do. Sulfuric acid just it will acidify the solution, and hence it will helps to produce ions. Alright, and these ions helps in the conduction of electricity. We can say that. Alright, I'll come to it once more to that particular part. But before that, I need to tell you something else. Now, you see that copper conducts electricity. Copper metal. And copper sulfate solution also, it conducts electricity. Alright, both of them conduct electricity. Then what is the difference between the, the conduction of electricity between a metal and an electrolyte? Rather, I am asking a difference between the conduction of electricity between metal and electrolyte. So, in your exams, anything may come. Like a difference between copper and copper sulfate means metal and electrolyte. Big difference between sodium and sodium chloride, aqueous sodium chloride or molten sodium chloride. What is that? Same thing, metal and electrolyte. So, listen carefully. Alright, listen carefully what I am saying. Now, copper conducts electricity due to the presence of free electrons. It conducts electricity. But copper sulfate solution conducts electricity due to the presence of free ions. Mind it. Electrolyte conducts electricity due to the presence of free ions. Due to the presence of free ions, it conducts electricity. Fine. Next it. After that, when the electrolytic decomposition takes place, it's a chemical change. Definitely, it's a chemical change. A new product is being formed. But when current flows through a copper wire, for example, you have seen it in your house, the current is flowing through the help of what? Copper wire. Any decomposition is taking place? Nothing. Because you switch off, again you switch on. The same copper wire will be there. But once you pass current through an electrolyte, decomposition takes place. A chemical change takes place. We can say that. Decomposition. Copper sulfate dissociate to give you, what is that? Nothing but Cu2 plus and SO4 2 minus. It's a decomposition which is taking place. Isn't it? Clear? So it's a chemical change, we can say that. There is a decomposition of the electrolytic solution. The chemical properties of the electrolyte is being changed. We can say. You can see it is being changed. Alright? Where the copper ions goes to the cathode and sulfate ion will go to the anode. We can say that. Clear? If it is a molten copper sulfate, you have taken it. Clear? Achha. Now, next. Metals, they are good conductors of electricity in the solid state. But electrolyte, they are good conductor of electricity in the fused state, in the molten state or in the aqueous solution state. Same thing. Because metals conduct electricity by the help of electrons. In the solid state, the electrons are available. But electrolyte, in the fused state or in the aqueous state, because in that particular state, ions are available. Alright, and due to the availability of ions, it conducts electricity. Now, in case of electrolytic, this conduction, there is transfer of ions. You know that. That means a matter is being transferred. Yeah, this is matter. It's being transferred from one position to another position. But in case of the current which is conducted by metals, alright, that is metallic conduction. There is no transfer of any metals. There is no transfer of any matter. Matter remains there only. Is copper moving from one place to another place? No. Only free electrons is moving. But here there is a transfer of matter. Matter is being transferred from one place to another place. We can say that. Listen carefully. But in case of metallic conduction, there is no transfer of matter. Copper atoms, copper molecules remains as it is inside the copper wire. Alright, it's a physical change, I have already said you. There is only transfer of electrons, free electrons, that too free electrons I am saying you, free electrons. It moves. The free electrons means electrons which is present in the valence shell. That is moving from one place to another place. There is a transfer of free electrons. No transfer of matter is being taking place and no new product is being formed. It's a physical change, always I have said it. Got it? Clear? So in this way, copper, what you can say, or the metals you can say, transfers electricity, or the conduction of electricity takes place in metal by the help of what you can say, nothing but free electrons, and there is no decomposition is taking place. But here it is taking place with the help of free ions, and the decomposition of the substance takes place. Got it? Clear? So in this way, you see the difference between the metallic conduction and the electrolytic conduction. You saw the difference between. Got it? Next, after that, I told you just now, I was speaking to you that I will tell you about, that is when the ions are being conducted, what it happens. Got it? Now, ions means, suppose previously if you have seen it, that is I wrote two equations, I wrote it. Got it? Two equations. That means you are having there two different types of cations and anions. Got it? Now, when two cations and two anions are being present, got it? If you have forgotten, once again I am writing it and I am showing it to you. Got it? See here, just now I was talking about acidified water, acidulated water. In that case only just I said you. For example, you see here H2O, H plus plus OH minus. That is the two types of ions are there, cations and anions. H2SO4 will give you 2H plus plus SO4 2 minus. You can see here. Clear? You can see H plus and OH minus, and here is 2H plus and SO4 2 minus. You can see that. Clear? This is known as acidulated water. Just now I was talking to you. Clear? So two types of cations and anions. Cations is of one type, rather you can say that, and anions you are getting two types. Clear? Understood? Now, in this case, when there is two cations and two anions is present, now the question definitely should come into your mind, sir, which will go to the cathode and which will go to the anode? Which will go to the cathode and anode? Rather, I will give you one more example. See here. That is aqueous sodium chloride dissociates to give you Na plus plus Cl minus. Aqueous means water, or NaCl solution also I can say that. It will dissociate to give you H plus and OH minus. You can see here two cations and two anions. Now the question comes, when we write the electrolytic reaction, which will go to the cathode, which will go to the anode? Yes. Now we need to understand a series. That is called as electrochemical series. Very, very important. Listen carefully. Electrochemical series. Now, what is electrochemical series? Depending on the ease with which the metals lose their electrons and form ions, they are arranged in a series, and that is called as the electrochemical series. Depending on the ease, alright, with which the metals lose their electrons and form ions. Alright, depending on the ease, how easily a metal loses electrons, got it, and form ions, and as a result they are deposited at the respective electrode or they are discharged at the respective electrode. Got it? It depends upon a series, and that is called electrochemical series. Again I repeat, depending on how easily, got it, depending on how easily a metals lose electrons, got it, and they form ions and they are discharged. Not only they form ions, they are also discharged at the respective electrode. They are being collected or they are being deposited or they are being evolved. If it is gases, they are also evolved from a particular electrode. It is being placed in a series, and that particular series is called preferential, what you can say, series, or electrochemical series, also called as preferential series, or preferential discharge of ions also it is being said to be as, or in certain books it is written selective discharge of ions. Same thing, meaning is the same if you go through it. There is no difference. Got it? Now, next is, what you will find is that in this particular series, let me write it here, in this particular series, that is, we are having, Peter cannot manage all zeal in love, hate, care, much sincerely. So here see, I have made a series, an electrochemical series. I have written it: potassium, calcium, sodium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, and silver ions. The ions. Got it? So at the top of the series, I will be keeping the one. I have kept the one. How I have made the series? I am saying you. At top of the series, I have kept the one which is discharged with difficulty. Discharged. The ions are discharged with difficulty. that I have kept at the top of the series. With difficulty the ions are discharged. Alright. Now the difficulty level goes on decreasing, and at the bottom of the series I have kept the ions which are discharged easily. The ions which are discharged easily. That means I have arranged the series in the decreasing order of the difficulty level. The ions which are discharged easily means which are ionized as well as readily discharged. After ionization also it has to discharge the respective electrode. Got it? So they are being kept at the bottom of the series. And the one which is discharged with difficulty, it is ionized but it is not discharged at the respective electrode. Alright? That means that is being kept at the top of the series. Will is said to be as. Clear? So what we find, this is for the positive ions. Similarly we have also got for the negative ions also we have got it. Okay? I'll discuss it. Thank you very much.